Hey everyone, today we'll be discussing the components that are needed to create a moment or a torque. Throughout my videos, I use both moment and torque. For my tutorials, I may say in one instance, oh, this moment acts in this direction, or this torque acts in that direction. However, they are used interchangeably because they mean the same thing. So what does it actually mean? A moment or a torque is a force that produces rotations about a pivot point. So that pivot point is static. It does not move. It stays. It's like pinned. For example, door hinge or your actual elbow joint. That doesn't move. However, the levers or the things that are attached to it does rotate about that pivot point. With that being said, we can just kind of go look over here at this first example. This is our pivot point. When tackling a problem, identify what area the object, most likely the segment, is rotating about. So any force, as we can see there's a force here, you could draw the force like that, or even, since it's a vector, just to understand the line of action, you can draw it here. So we know there's a force acting downwards, right? And this, when you press down on this, let's use this. Say this is our pivot point right here. I'm holding it down, this pen down, so that way when I pull on this, it causes the Sharpie to angularly displace itself about the pivot point. How do we know it's being angularly displaced? Well, if we trace it, so this force applied for some time away from the pivot point causes it to move like so. So we can draw sort of here, right? And this angle is its displacement. So let's just say, moved 1.7 radians, or maybe 30 degrees, right? This, a moment or torque, causes angular rotation and angular displacement. There can be many torques acting at one system. Like this is for example, this looks like a seesaw. You can have forces acting at different parts of the lever. You can even have a force over here, force down here, a force up there, force pointing diagonally in. So it's just that you have to understand how to kind of decipher the questions and know which forces are pertinent. Now, another component to a moment is the distance that force is acting, or the line of action is away from the point of rotation, or the axis of rotation, or the pivot. So this R1 represents the distance from the point of rotation in which this force 1, is acting. So this defines what a moment is. It is the moment up here. Sorry. M is equal to a force multiplied by its perpendicular distance. Now, what does this mean, perpendicular? It is the distance away from the pivot point that when you trace it back, it hits the force or the line of action at 90 degrees. So over here, this is at 90 degrees. So we know this distance away from the pivot point is the perpendicular distance. Over here, same thing, 90 degrees. So know where your perpendicular distances can be found. Sometimes you might have to use trigonometric functions to figure that out. So please examine the equations properly, or the questions properly, sorry. Now, sometimes you can be asked calculate the force when you're given a moment. So it's important to understand the units. So for a moment, since it's the product of the force and the perpendicular distance, it is, we know a force is in newtons, and this unit is always going to be in meters. Why? That's just what we have defined a moment as. So if you're given centimeters, convert it to meters. A force is newtons, and the perpendicular distance is in, like we said, is in meters. Alright, so hopefully that kind of clears some stuff up for you guys. And once again, a moment of force causes angular rotation about a fixed pivot point. So know where your pivot point is. There could be many moments acting on a system, so that's an important implication to understand if a problem is dynamic or static. And the equation for a moment or torque is the force multiplied by the perpendicular distance, the shortest perpendicular distance away from the axis of rotation, also known as the pivot point.